Hi guys, it's Asian Biology Tutor here, and today we're going to look at paper 6, Alternative to Practical paper. It's for 2022, October, November. I actually didn't know it was called ATP, Alternative to Practical. It's not from respiration, of course, but let's get on with it. Okay, so number 1. A student investigated the vitamin C concentration in 3 different health drinks, A, B, and C. The concentration of vitamin C can be estimated in a sample of health drink by testing it with iodine solution. Usually, paper 6 gives out the CPIP as the testing solution, but in this case, it was given iodine solution. The test involves adding drops of iodine solution to health drink sample until the sample remains blue-black. Okay, so as you guys probably know already, iodine solution is often used to test the presence of starch. So iodine solution is a brown or yellow-brown color, and if starch is present, it changes its color to blue-black. Okay. So let's continue. The greater the volume of iodine solution added, the higher the concentration of vitamin C in the health drink. Okay. If I may give you a tip on paper 6, it's very important to understand every step of the method, in the method. So you actually have to understand what's going on here in order to analyze, what's going wrong and what are the things that are actually going according to the experiment and the purpose as well. So it's very, very important for you to read thoroughly when the instruction is given. So let's get on with it. The student used this method. So step 1, label 3 test tubes A, B, and C. So there were 3 test tubes A, B, C. Use a syringe to add 1 cube centimeter or 7 centimeter cube of starch suspension to each test tubes. So starch suspension was added to each test tube. Okay, and then used another clean syringe. This is good. The student actually used a very good technique here, using clean syringe to add 3 centimeter cube of health drink A. So A is given, health drink A is put into the test tube A. Health drink B was put into test tube B, C to C here. And then he used a dropping pipette to add 1 drop of iodine solution. Okay, so iodine solution was, we'll just use this. Okay, this is purple. Let's use something that's close. We'll just get on with it. Doesn't matter. So, okay. So the iodine solution was put into test tube A first. It was shaken to mix the contents. Yep. And then repeated step 6 until the color of the test tube or the contents in the test tube turned to blue-black. Yeah. So I guess it was initially brown because the iodine solution was put in to the test tube, and then changes color to blue-black. So I'll probably just explain what's going on here. Okay, So this method is actually determining the vitamin C concentration in solution by a redox titration. Yes, bit of chemistry here. And the vitamin C, it's actually called ascorbic acid. Just probably use another one. Okay. So vitamin C is actually called ascorbic acid. So this is the proper name. So as the iodine or iodine solution is put during the titration, ascorbic acid reacts with it and it gets oxidized to dihydroascorbic acid. Okay? And the iodine is, of course, reduced to iodide ions. It's like iodine here. Okay, so this is the oxidation and this is the reduction going on. So due to this reaction, iodine that's formed is immediately reduced to iodine is reduced to iodide, and that happens as long as there's any ascorbic acid present. So once all the ascorbic acid has been oxidized, the excess iodine is free to react with starch if starch is present. And that's going to change the color of the iodine, which is brown, to blue, black. Okay? So, because at the moment we are dropping, or the student is dropping iodine in solution. And if he had to drop, let's say there were two test tubes, A and B. If the iodine solution was put in A, and let's say the student dropped seven drops of iodine solution and changed color to blue black, and for B, he or she had to drop, let's say, 10 drops of iodine solution to change, or to see this color change from brown to blue black. That means B has more ascorbic acid, vitamin C. Because after 7 drops for A, so after 7 drops, all the ascorbic acid was oxidized, and then the starch changes to blue black. For B, after 10 drops, more iodine solution reacted with more ascorbic acid, it now reacted with the starch to change the color to blue black. So basically, more ascorbic acid was present in B because it needed more iodine solution to see starch to change the color. Okay? So that's what's happening here. So let's continue. And the step 8, record the total number of drops of iodine solution added to test tube A, and that same thing goes happened to B and C. Okay, and then in step 10, test tubes A, B, and C were cleaned up. Okay, and he or she actually did that in order to repeat the experiment 3 times. Okay. The student used the same test tubes, so he or she had to clean it up to use it again or use them again. So the student repeated the experiment 3 times, which was pretty good. And then the student got the results here. Okay. And of course, for paper 6, you always get to make table using these results. So I've already made a table for you guys, and it's very important to identify what to put as heading. So you actually need appropriate headings for each column and row. So very often, the things that you're measuring actually goes on the top. So dependent variable here is the number of drops in test tubes. So that's what you're measuring, or the student is measuring. So the heading for that goes at the top. And then in this case, the number of trials goes to sideway. So I'll put a test tube A, B, and C here, and then put all these results here, and then get the average, because the question is asking you to include the averages, the average number of drops of iodine solution used for each solution. So here are the average values, and that's the table that you should draw. And let's go to number 2. Suggest a reason why the starch suspension was added to each of the test tubes in this investigation. So like I said before, starch suspension was an indicator. Oops. So as the iodine solution changes color, when it reacts with starch, it is used as indicator. Okay, it's used as the indicator. So 1 mark for that. Actually, we got 4 marks for this one as well. And state which health drink, A, B, or C, has the highest concentration of vitamin C, and give a reason for your answer. I guess it's B, right? Because on average, 17 drops of iodine solution was needed to see the color change. So it's only a 1 mark question. However, you have to say B and say why. You have to state why as well. So it's B because the test tube B needed more iodine solutions or drops of iodine solutions than the others. Number 4, identify the variable that was measured. So the dependent variable. So the dependent variable is the thing that you're measuring, the things that are changing. And independent variable is something that you change or that the experimenter changes. So in this case, it's the number of drops of iodine solution. Okay, number 5. Explain why it was important to use a clean syringe in steps 3, 4, and 5. Of course, well, you want to use the test tube again, so you don't want to have the contamination, right? Contaminations from the previous experiment. So the student cleaned the syringe to prevent contamination. Number 6. Identify one possible source of error in steps 6 and 7. And you have to suggest an improvement. So let's go to step 6 and 7 here. It's a bit dirty, so I'm just going to clear the page. 6 and 7. Use the dropping pipette to add 1 drop of iodine solution. Okay, so I guess the student just used the dropping pipette, and the dropping pipette is not accurate at all. The volume of the solution is not actually measured properly. So that's the bad thing. That's the error first. So in order to improve this, student could use syringe. Which means the drop size can actually vary. The first drop can be quite large, and the second drop can actually be small, depending on how much pressure you put on to the dropping pipette. So it's the size of the volume of the solution is inconsistent. So improvement, the student could use syringe. Oops, my bad. Or could use, I guess, measuring cylinder. Measuring cylinder is always good because I like this one because it says measuring already. So it kind of gives you a hint of what it does, right? Of course, there are like burettes and graduated pipettes, but I think it's easier to remember. So I often use measuring cylinder. Okay. Okay, let's go to. We can actually talk a bit more about this because it says 6 and 7. So let's have a look at 7. Repeat step 6, counting the number of drops added until the color change. So seeing the color change is actually subjective. Okay, we're all different, and watching something that's something that's happening can be perceived differently. So it's quite subjective. So for this one, the best way is to see the color change is to use colorimeter. This is a machine, and it's like MasterCard. You can just use it anywhere, any papers. When you're encountered with a question that asks about the color changes, like how you detect the color change, always just go for this one. Just go with this colorimeter. That's the best answer. Simple answer. Let's have a look at number B. A student prepares 6 vitamin C solutions of different concentrations. They added drops of iodine solution until each concentration of vitamin C solution remained blue-black. So it's very similar experiment. Very, very similar. This experiment was repeated 3 times, and the average number of drops of iodine solution added was calculated for each solution. Or each concentration. Okay. By looking at the table, you can see that as the percentage vitamin C concentration gets increased, the average number of drops of iodine solution added also increases. However, I can see anomaly here in trial 2. And let's just get on with the question. The student decided that the result for trial 2 of the 0.05%, so this one, anomaly 1, vitamin C solution was anomalous. State what is meant by an anomalous result. So anomalous result or anomaly is the result that doesn't really fit the pattern or the trend. So as you can see, this is actually much higher than 4 or 6. So this is what we call anomaly or anomalous result. Okay, this type of question comes out quite often, so you have to know what the anomaly is. Okay, that's gonna give you 1 free mark. So keep that in mind. Okay. So let's have a look at number 2. State how the student dealt with the anomalous result when calculating the average value for the 0.05% vitamin C solution. So even though the anomalous result showed 19 drops, the average was calculated as 5. So you can see that this was excluded, and then the student got the average value between 4 and 6 of 4 and 6. So excluded is the answer. And that's a common technique that everyone use. Okay, even in your experiment, if you ever get the anomalous result, you just can simply exclude it. Number 3, using the data in table 1.1, plot a line graph and the grid of the percentage vitamin C concentration against the average number of drops of iodine solution added. So I've already made the graph for you. You gotta be careful with this one, because if you look at the x-axis, this one, the values are not consistent. I mean, they are consistent, but I'm just saying the intermediate values are not consistent. So you can see it starts from 0 and it goes to 0.025 and then to 0.05 and then it goes to 0.1. So the increment is not consistent, and then it changes from 0.1 to 0.2 and then it goes up to 0.4. So see, you can see there's a big jump between here and here as well. So you don't actually have to use, the end part. I mean, you don't actually have to use the whole thing. You can just use, let's say, majority the space in the grid. So since the last value is 0.4, I'm just gonna use 4 sections, like 1, 2, 3, 4 sections. So I'm just going to use this area to draw the graph. So 0.4 is written here. So I'm just going to use the consistent increment of 0.1. Just start from 0.1, 2, 3, 4. And then I'm just going to plot it. Just read carefully with the average values and these percentage vitamin C concentrations as well. So just plot it, and then you get this. Always don't forget to write the x-axis and y-axis titles, not the titles, headings. And of course, you have to be very careful because they're quite picky. So I mean, some teachers can be very, very quick, picky and comment on this. So you gotta put the line on the line or draw the line on the line. And many of my students actually ask me if they have to draw a line of best fit. You know, the line goes like this, something like this. Oh, that's an automated one, not a good one. Something like this. But no, you actually have to write or draw a line of best fit if the question asks you to do so. Okay? The question doesn't actually ask you to write or to draw the line of best fit. So just plot all the 6 points correctly like this, and then draw a line or lines connecting the dots or the points like this. Okay. Don't forget about the units. Of course, in this case, it doesn't actually have unit here written. It says percentage here, but usually the table gives the unit like this. Since it didn't, I omitted it. I didn't put it. But I think you can actually put it. I think you can just put the unit here as an extra indication. There's no unit for the drops, so you don't have to write the unit for the drop one here. And this is how you get all 4 marks for the graph. Okay, so this is the graph that you want to draw. Like this. Okay. Let's go to number 4. The student was given a health drink, D. It took 7 drops, okay, and then turned to blue-black. And you have to estimate the vitamin C concentration. So this is easy, right? So you just have to figure where 7 drops is. So it's here. So if you just draw a line and then draw another line like this, you can get the percentage vitamin C for this question. So that's around 0. You can actually do approximate value, so I would just go with 0.7, or you could just go like 0.68 or something. Doesn't actually matter, or because there's a range. Okay, there's like plus minus half a small square or something like this. So yeah, there's a range for your answer. So I don't think they actually are very picky on this one. So just choose anything between 2, okay? Number 5, describe one way in which the method for testing a substance with Benedict solution differs from the method for testing substance with Biuret solution. So it's talking about the one way in which the method is different. Okay, so Benedict solution. For Benedict solution, you actually have to hit it. This must be heated. Whereas for the Biuret solution, which tests the presence of protein, doesn't actually need heating out. Okay, doesn't actually need the heat. So Benedict solution must be heated. Okay, must be heated. My bad, must be heated. Okay. Okay, let's continue with number 2A. So for this type of question, it's actually hard to do it using my iPad because if I just do this, the length will change. If I just zoom in and out, it's gonna change the length of it. But it's pretty easy, right? Because all you need to find is the magnification, or you have to find the actual length or the image length. It's quite often it asks you about the actual length or the magnification. You just have to measure it. So it says measure the length of the line, so you just have to measure the line, which I don't actually know. It can be anything. It depends on the paper, actual paper that you're given. So let's say the length of the line is about 70 millimeters, like 7 centimeters. Then the magnification is, of course, 0.3 here. So 0.3 equals to the length of the line. And the actual length is the one that you had to find. So it's pretty basic, right? So now A equals to 70 millimeters divided by 0.3, which is around 210 millimeters. That's how you get it. Pretty easy peasy, right? And number 2, you will always get this type of question. You have to draw the large diagram of the speechman that you're given. And there are several things that you have to remember. You have to draw a large diagram, which means you have to draw a big one. So I've actually drawn one for you. So you have to draw it very clearly. So you have to draw in single lines. You can't draw like this. If you want to make or draw a line, you can use 2 lines for 1. So the lines should be straight. You can't break the line between. And you'll be given marks for the details. I'm not actually talking about the details like these details. You can see a bit of foldings here, the lines here. You shouldn't draw. You shouldn't draw these type of details. You only have to draw the details like the actual shape, the overall shape, and a bit of details inside. Okay, like these ones. And you can actually see there are a few lines that are darker than the others. So these lines are darker, so you have to draw them. So this will be the ideal drawing. So it's pretty big enough, and it's got some details, and that's how you get 4 marks. It didn't actually ask you to label, so it's okay not to label. And that's it. Okay. Number B. Identify 2 differences between the Queen Alexandra's birdwing caterpillar in figure 2.3 and monarch butterfly caterpillar in 2.4. So you just have to see the difference between these two. They're pretty basic, pretty straightforward, right? So things that I'm gonna say or write will be, this one has stripes. So stripes. And let's see. This antennae is another one. And round legs. And you can actually identify the head, but you can't really identify which one is the head, right? And this one has a lot of spikes. And that's pretty dark. This isn't so. So that's pretty easy. The question was pretty easy. It's like easy 2 marks for that one. Let's go with the C. Okay, caterpillars turn into butterflies after pupating. A scientist investigated the effect of temperature on the number of days taken for a caterpillar to become butterfly. Collected 120 caterpillars of one species. They were at the same age. That's good. 4 glass houses were prepared in different temperatures. So 30 each. And they were given the same mess of food, which is good. It's all controlled. And state 2 variables that were kept constant in this investigation. So it says already, right? One species. So species were kept constant. The types of species. Same age. Mass of food. And the number of caterpillars. And they're all kept in glass houses. It's probably same glass houses. And says, okay, 30 to 60 days. So days, time, right? The number of days as well. This type of question is quite easy if you just read the whole thing carefully, because the answers are always in the passage. So just focus, like read it thoroughly, because you'll be given enough time, always. So practice on reading the passages carefully, because like it's really, really easy marks. They're easy marks to get. You don't want to miss them, okay? The next one comes quite often as well. Many questions ask percentage change. Calculate the percentage change in the number of caterpillars remaining between 30 days and 60 days when the temperature was 15 degrees Celsius. Okay, so how do you get it? So you have to find the temperature first, the right temperature. And it changes, the number changes from 26 to 25. So that's the initial value, and that's the final value or numbers. So the formula to calculate the percentage change is final value minus initial value divided by initial value times 100. So in this case, it's 26 is the initial one, so we're gonna go with 25 as final one. Oops, 26 here. And times 100 will give you 3.8, negative 3.8. So you can't say it's negative 3.8 because it asks you about the percentage change. If the question asks calculate the percentage decrease, which in this case it did, you have to take out the negative sign, the minus sign, okay? Since this question actually asked about the percentage change, the change is negative. You have to, don't forget about putting negative sign here. So it's negative 3.8%. So you get 3 marks for this one. Number 3. Use the information in table 2.1 to suggest the optimum best temperature for changing from a caterpillar into a butterfly. This question is quite simple because you just have to find the temperature that completely changes the caterpillars into the butterfly. So if there's 0 number of caterpillars remaining at 60 days, that means all the caterpillars were changed or converted into the butterflies. So 25 degrees Celsius will be the optimum temperature. Number 3. Plan an investigation to determine the effect of temperature on the rate of photosynthesis in an aquatic plant. So for this type of question, many students actually struggle with this type of question, but there are some formats that can be quite useful if you guys can remember it. Often, the question number 3 in paper 6 actually asks you guys to make an investigation that's quite similar to number 1, question number 1. So this one. Okay, this. I'm not talking about this topic, but just the very first question. However, I mean, if that happens, then you guys can actually copy all the methods. I can just slightly change the methods, like some bit of the details of what is being involved and what's going to happen. But if you get asked to make or plan an investigation that is completely different from question 1, the very first question, the questions are they tend to be quite simple. However, good thing about this is that you guys don't actually have to write the proper like experimental proposal or anything like that. There's something you guys just should remember, which is a format. So whenever you guys start with planning an investigation, just write independent variable. It's like mentioning things before you let's say describe. So you have to write the independent variable, and then you have to write dependent variable here. Next, and then you write control variables. So in this way, you will give the marker or your teachers or teacher that you know what to do. You actually do know what to do, and they'll read it thoroughly. And even if they don't read it thoroughly, they kind of get the idea that you know the answer for this. And if they can't be bothered reading all methods, all investigation, then they'll just keep looking. Oh yeah, he knows what the independent variable is. He knows what the dependent variable is. He knows what he or she knows all the control variables. So they'll probably just mark it, even if you get like slightly wrong in actual method part. So always just tell them or show them what you know, and that the fact that you actually know. So if you are about to investigate the effect of temperature on the rate of photosynthesis, the independent variable should be the things that you control, right? You change. So things like the temperature, right? This is the independent variable. So you actually have to give a specific numbers. Let's say 25 degrees Celsius, 30 degrees Celsius, 35 degrees Celsius, and 40. Like this. All these variables should be more than 2. Right. There should be more than 2 temperatures in this case. And for the dependent variable, it's something that you're counting, right? You're measuring. So the rate of photosynthesis is often measured by the gases, like the oxygen gas that's given off from photosynthesis. So you probably want to count the bubbles. You can also measure the volume of gas that's formed. And for control variables, you want to write more than 2, like always. Because quite often you get 1 mark for independent variable, you get another one for dependent variable. minimum 2 marks will be given for the control variables. So ideal number for the control variables is 3. Okay. So if I were you, I'll probably just write 3 control variables. Since we're actually using the temperature here, easiest way to figure out the control variables is, of course, volume. We're using aquatic plants, so the plants should be in water. So the volume of water should be controlled. They have to be kept constant. And also pH is an easy one to remember, pH of water. And since we're using plant or organism, we have to keep the species the same. And probably the size as well. And masses should be the same as well. I can say mass of plants. And since we're testing on photosynthesis, the carbon dioxide that is provided should be the same, like carbon dioxide, volume of the carbon dioxide or concentration. And since it's light, the photosynthesis is using the light, so the light intensity should be kept constant as well. So any 3 of these should be fine. So already you've got 5 marks. Okay, and then you have to write about the methods. Like I'll probably write in sentences. I'm not going to write in bullet points, but the things that should be kept or should be written in the methods is basically like I would just give like 1. I'll write 1, blah, 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 you do this. 2, blah, 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 you do that. And 3, blah, 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 you do this. That kind of stuff. So always put the apparatus, like equipments, right equipment. Things like, because you're going to count the bubbles. You can, I guess, count them by, observing them. If you're measuring the gases, then you have to use syringe, like gas syringe. And of course, you're handling the temperature. You're changing the temperature, so you'll have to use the machine. I would say thermostatically controlled water bath is the good one. Like ages ago, it was okay to just say you guys gotta use water bath. But in these days, they're more specific. So a thermostatically controlled water bath is the term that you want to use. Okay. And you will have to, let's say, actually, I'll give you a hint as well. You're trying to get or measure the amount of gas that's formed, which is the oxygen. And you can simply just write the amount of oxygen gas that's formed can be measured by oxygen probe. Okay, so oxygen probe is a machine, it's a device that can measure the amount of oxygen that's formed. So using all these equipments, like putting all these equipments into your methods, they'll gain 1 or 2 marks. And this is most important part. It never changes in any investigation planning. So I'm just going to draw a star. So you will have to repeat the investigation at least 3 times. I'm saying 3 times because I think the mark scheme actually says at least twice, but it's always just good to say 3 times. It works every time. So I'll just go for repeat the investigation 3 times. This alone will give you 1 mark. So it's like free mark. Don't ever forget it. Okay? So practice on this. I mean, writing this method part like in sentences isn't going to be too hard, because if you write all the variables above, then it's very likely that your teachers will just give marks reading the top ones, not the actual one. So you will already get 5 marks from the top one, like writing the variables, and then you will get 1 more mark for repeating. That's total 6 marks. Okay, so if your teacher is lazy, he or she, your teacher, you're very likely to just read the top part and the bottom part, and probably just neglect the middle one, and give you all 6 marks. So this is 1 hint or 1 tip that I can give to you. Okay? And that's it. Okay. This was my first paper 6 explanation, so it was a bit slow, I guess. But please understand my first trial, and I'll post a few more up as soon as possible. Okay? Hey, thanks, guys.